All right, let's talk about acceleration. Last notes we talked about speed. How fast does something go? Or how much time does it take for a change in position? That's really what speed is. All right, it's a rate of change in position. So now we're going to talk about a thing called acceleration. And acceleration is actually it's really kind of a complicated concept. Even though when you're riding in your car, it doesn't seem really complicated. It's like you press on the gas and you accelerate. Which now think about the idea, what does that mean if you step on the gas and you accelerate? What is that? What did you change? Well, you changed how fast you were going. So it's going to turn out that acceleration is a change in speed, right? So, but to start off with this, we're going to look at something else to begin with that goes along with acceleration. And I have a little story at the beginning of the notes that said RDB story. What that is, I was going to read to you just a little paragraph on a story about some bees. So listen to the story. It says, you turn on the radio and you hear the tail end of a news story about a swarm of killer bees. You can even call them murder hornets based on this year. The swarm, moving at a speed of 60 kilometers an hour, has just left a town 60 kilometers north of your location. Should you be worried? What should you do? Now let me read it one more time, now that you've heard the whole story and you know what the questions are at the end. You turn on the radio and you hear the tail end of a news story about a swarm of murder hornets, right? The swarm, moving at a speed of 60 kilometers per hour, has just left the town 60 kilometers north of your location. Should you be worried? What should you do? So, first of all, yeah, should you be worried? Well, they're traveling at 60 kilometers an hour. They're 60 kilometers away from you. How long is it going to take them to get to you? Well, if you think of that in your own mind, they can travel 60 kilometers in 1 hour, and you're 60 kilometers away. So that means you got an hour before these murder hornets are going to get to your place where you're at. Now, murder hornets are like that big, right? So, if you want to compare it to me, it's like the size of my ear, right? Or half the size of my eyeglasses. That gives you an idea of how big they are. Oh, but wait a minute. It said they were, where were they? They were north of us. So, and all it told us is that they were traveling 60 kilometers an hour. So which direction are they going? Are they coming south towards us? Maybe they're going north. Maybe they're going east. Maybe they're going west. We don't know. So because we don't know the direction they're going, now I'm not sure if I need to worry or not, because I don't know if they're actually traveling towards me. So what we really needed to know is we needed to know how fast they were going, 60 kilometers an hour, and we needed to know the direction that they were going. Are they going north? Are they going south, going east, going west? And it didn't tell us that. So there's the little dilemma inside that little story, and that's why I like to read that little story. And that takes us into our notes. So in our notes, it says, first thing, just as a little quick review that we just did, is that speed is a measurement of how fast something is. How much of a change in that your location, where you are. How long does it take you to get from one place to another? That's what speed is. It doesn't tell us direction. It doesn't tell us where the object went, what direction it went. So we have to get another term, and that's letter B, and that's called velocity. And velocity is speed and direction. It gives us two things, right? So we'd have to look at two cars, or if we looked at two cars that were going in different directions at the same speed, actually, even though they're both going 55 miles an hour, but they're going that way, right? One's going one direction, one goes the other. They actually have different velocities. They have the same speed because they're going the same number of miles per hour, but they have different velocities because one's going east and one's going west, right? So letter C, how would you make your car's speedometer a velocity meter? Well, what you'd have to do is you'd have to attach a compass, which a lot of cars now have them on the rear view mirror right up here. There's usually a little spot that tells you the temperature, and it also tells you the direction you're going. You're going north, going south, going east, going west, going southwest. So that actually adds to your speedometer that's on your car that gives you that, what we talked about the other day, instantaneous speed. And now knowing what direction you're going, you now have a velocity meter in your car, and you know which direction you're going and how fast you're going. So that's what velocity is. Velocity is speed and direction both. All right. So now let's look at acceleration. All right, and again, I just told you at the beginning of this thing that acceleration is kind of complicated. Acceleration is a change in speed. It's the rate of the change of velocity. So actually I just misquoted because I said change in speed. It's actually a change in velocity. So if it's a change in velocity, then that means it can be a change in speed, how fast I'm going, and it can be a change in direction. Right? So we'll start off with the easy one and think about the idea of change in speed. You're sitting on a drag race in your car, all right, and you're going to drag race somebody. When you're sitting at the starting line, how fast are you going? 0. You're not going at all. You're traveling at 0 miles an hour. You, boom, hit the gas pedal, take off. You're flying down the dragway, and you hit 100 miles an hour. Right? So you changed your speed. You went from 0 to 100 miles an hour. Now, how long did it take you? Well, let's say it took you 5 seconds to get to 100 miles an hour. That's pretty amazing. But it took you 5 seconds to get to 100 miles an hour. Well, that's your acceleration, right? Your acceleration is you accelerated at 100 miles an hour in 5 seconds. Okay? So I'm going to write this behind me and go, so acceleration on this would be 100 miles per hour per 5 seconds. Now I want you to notice in that unit is we've got distance, which is miles, and then we got hours and we got seconds. So notice there's 2 units of time inside there. This unit of time up here tells me my speed. This unit of time tells me how long it takes me to change that speed. Right? So acceleration always has 2 units of time inside of it. Okay? Now a positive acceleration, like in the case of this one, because that's a positive 100, that means what did my car do? I think the idea, we were on the drag strip, I stomped on the gas pedal, it took off. What did my car do? It speeded up. It went faster. So a positive acceleration means I go faster. I accelerate. Now what if at the end, all of a sudden, let off on the gas pedal, pulled my chute, so also I get this big parachute behind me, and all of a sudden I do what? I will decelerate. So I'm going to go 100 miles an hour all the way down to 0 in a certain amount of time. So all of a sudden I'm going to have this negative 100 miles per hour per, let's say it takes us 10 seconds to slow down. So it's going to be a negative 100 miles an hour per 10 seconds. And this is deceleration because it's a negative. So a negative acceleration means you're slowing down. A positive acceleration means you're speeding up. Right? All right, so now let's look at the idea of direction. All right, so let me erase this piece right here. You're traveling this direction. Right? You're going down the road, going that direction. You're coming up to a turn. So right up here, the road does this. All right, so it's going to turn. Well, and we're going, let's say we're going 30 miles an hour. I know I'm using English units, miles an hour instead of kilometers an hour. I'm just using miles an hour because that's something we're more used to right now. And hopefully down the road in years to come, we'll get more used to the idea of kilometers an hour. But you're going 30 miles an hour coming into this turn, right? How fast are you going that way right now? Right now, while you're right here, how fast are you going in that direction? 0. I'm not traveling in that direction, Mr. Pape, on my watch. But my speed in that direction is 0. Now let's assume, this is a scary thought, let's assume we don't let off on the gas pedal. As a driver's ed teacher, that would be an exciting moment going around the corner at 30 miles an hour. But you go around this corner and never let off on the gas pedal. Now remember, down here, my speed going this way is 0 miles per hour. Once I go around this corner, up here, now I'm going to be going 30 miles per hour that way. Yeah, I accelerate. Well, now when you think about it, you go, no, you didn't accelerate. You're going 30 miles an hour. You're going 30 miles an hour and never accelerated. You didn't speed up. Your speed didn't change. But did it? Now, remember, we're not really going to talk about speed. We're going to talk about velocity. My speed going this direction down here was 0. Once I go around the corner, all of a sudden I'm going 30 miles an hour. So I did accelerate when I went around the corner because it actually speeded up and I changed my speed as I went around the corner. So we can then say that acceleration is a change in speed and a change in direction. Both of those are considered to be an acceleration because you do change your speed when you do that. You could also say up here, you actually are going to decelerate because my speed that direction now is 0. All right, as I go around that corner. So I decelerate because I was going 30 miles an hour in that direction here. When I go around the corner, all of a sudden I'm going 0. Now think about, and this is something you can try at home next time you're out in your car and you go around the corner. Notice what it feels like when you go around the corner. You're cruising in the car with your parents, and all of a sudden they turn. Don't you feel like you're like, whoa, man, good gosh, Mom, why don't you put your foot on the brake as we go around the corner? Because, man, you're throwing me around the car. Why do you get thrown around inside the car? Because you're accelerating as you go around that corner. Even though that you're not changing your speed, you are changing it because you weren't going any velocity that way. But then all of a sudden you do accelerate in that direction as you go around the corner. All right, so it does. There's an equation for this, and that equation, which is in your notes, it is acceleration equals final velocity minus initial velocity. Then we're going to divide that by the change in time. Right? And if we do this as symbols, we would have acceleration equals velocity final minus velocity initial divided by triangle, which means change, and t is time. Right? So this would be it in words up here. This is the equation in symbols. Right? So we can figure this out again if we were on our drag race where we went from 0 to 100. My final velocity is 100 miles an hour. My initial velocity was 0 miles an hour. And then it took me 5 seconds to do it. Right? So what is this going to divide out? I'm going to take 100 divided by 5. That's going to give me 20 miles per hour every second. So I speeded up by 20 miles an hour every second. So in the first second, I was going 20 miles an hour. In the second, I was going 40 miles an hour. In the third second, I was going 60 miles an hour. In the fourth second, how fast was I going? 80 miles an hour. And finally, in the fifth second, right as I went across the finish line, I was going 100 miles an hour. Right? That's what this tells me, is how much did my speed change per every second. All right. Now, some other things that can happen is if we measure this in miles per second, this could also end up being in something like 20 miles per second squared. And that second squared would be taking both of the units. If the units of time are the same, we just make it squared. All right, well, that concludes our notes on velocity and acceleration. So we'll see you next time. Have a great day.